shows you how to start up the CD7 wide field microscope. On the base of the CD7, ensure the power switch is on, and then press the power switch adjacent to the LCD screen. Next, switch on the PC underneath the robot table. Wait for the CD7 touchscreen to finish booting, and then press the Eject Tray button. The plate holder will move to the load position on the right of the CD7. Place your plate or sample holder into the plate holder, ensuring it is in the correct orientation. A1, that is, top left, is nearest to you on the left. All further control is performed through Zen software. Once the PC has booted and the microscope is powered on and initialized, start the Zen software and the CD7 component. Ensure no sample is in the holder at this point. This startup takes several seconds, then is ready when you can access the sample carrier drop-down. Here you choose the sample holder or plate types that you would like to load onto the system. Those sample carriers in the workgroup templates list are those which the robot scheduling software are able to access. So it is useful to have your experiment use one of these templates if you require automation with the experiment you set up. I have chosen the multi-slide holder template Thorlabs 4x Frosted. Before loading samples, you have the option of requesting the CD7 carry out some tests on the plate which you are about to load onto the system. These are usually unnecessary, as the characteristics of the plates are preset in the sample carrier templates which you load, hence having different templates for different manufacturers of 96-well plates, etc. Measure bottom thickness will determine the cover slip thickness of your samples, or more likely the bottom thickness of the material on your multiwell plate. Similarly for bottom material, plastic or glass. Sample carrier detection is unreliable with the multiple plate types we have registered in the system, so should be left unused. Carrier overview will produce a top-down webcam image of the plate you've loaded, but is of little use in most cases, so can also be left off. The barcode option within Zen does not work with the plate holder we have installed in the system, so should be left unchecked. As you can see, we have the option of editing the values of material, refractive index, thickness and skirt height, but this is all set within the plate templates already, so can be ignored. Skirt height describes the distance from the bottom of the plate frame to the bottom of the optical surface, and is the most important parameter for the CD7, as it determines the area of the plate which the microscope lens can access. We also have slide templates for slides without frosting, and double width slides. Ensure your plate has been loaded into the CD7 in the correct orientation and with slides in the holders with cover slips facing downwards, as this is an inverted microscope. Then press Load Sample. The tray will be taken into the system and some skirt height measurements are automatically taken to ensure there is no chance of lens damage. Plate loading takes several seconds, and when the template overview is displayed, the sample is in position. At this point, you can move over to the Acquisition tab and the workplace zoom set to your desired level to determine your layout preference. The CD7 runs in Zen using experiments, so I've created a fresh one. However, you can use a pre-existing one if you already have one saved from the list. To set up your experiment, select Smart Setup and choose the appropriate imaging modalities and fluorophores on your sample. In my case, I'm going to be looking at a piece of tissue on a histology slide, which should autofluoresce, so I've selected several standard fluorophores. And you have the option on this system of a selection of transmitted imaging modalities, bright field, phase gradient and oblique. Next, we choose the camera you would like to use. either the Axicam 506 or the Hamamatsu Fusion. In most instances, the Fusion is the best choice. Arrange the screen layout as you prefer. Here, using the single container mode, we can see that the system indicates the range which any selected objective can reach on the chosen sample container. You can see that the 5x and 20x lenses are able to reach the entirety of the samples in the holder, whereas the 50x lens is unable to reach the bottom edges of the wells, or slides. Use of the 50x lens on slide is not recommended due to the likelihood of the meniscus coming into contact with the edge of the slide and leaking. The system is controlled using the tabs on the right-hand side, selecting lens and Optivar, and stage controls using a virtual joystick. However, it is often easier to navigate by double-clicking on the navigation window. Focus can be controlled using the slider, and we can see when changing lenses that the lens limits are highlighted. It is usually easiest to start with the 5x lens. I'll now swap back to container view mode so that we can visualize the image and also our navigation steps. You can see the channels set up here, overviewing the hardware configurations as set up by the Smart Setup menu, with channel 1 using a quad-band beam splitter and filter. You can see on the right-hand drop-downs different options available on the system from which Smart Setup chooses. In the case of DAPI, using the multipass beam splitter and emission filter, and utilising the 365 excitation LED, for example. Similarly, channel 2 and 3 are set utilising the same dichroic and filter set, but switching to use the 470nm LED for channel 2, which is Alexa 488, or the 625nm LED for channel 3, which is Alexa 647. This makes changing channels much quicker than having to change filters between channels. The fourth channel, wide field, does not use the same LEDs and instead uses a transmitted LED lamp with a 725nm wavelength, which is usable on any cube and does not require the filters to be removed from the path, and this keeps the imaging speed high. Once you are in a position on the slide where you believe your sample may be, you can go live on one of your channels to determine exposure and focal positions. To make things easier, I move the live image into the second container so we can see the navigation window and the live image. As you can see, the bright field image is too bright, as you can see on the lookup table, with the range indicator indicating overexposed in red. To alter this, I reduce the exposure from 10 milliseconds to 1 millisecond, and you can see the image comes within range on the LUT. You can now navigate around your slide to find your sample by clicking on the navigator, or on the live window to recenter around the point chosen. You can adapt focus using the slider on the right-hand side, or by holding control over the live image and using the mouse scroll wheel. If you are a long way from focus, it is possible to use the Find Surface tool to bring you closer to the correct focal plane, so only minor adjustments are necessary. Note that the Fusion camera is 16-bit and doesn't require the histogram to be filled in many cases. You can get usable images instead, keeping the exposure times to a minimum to keep acquisition fast. Even if the image on the screen appears dim, you can use the best fit option on the lookup table to adapt the image on the screen. Note that in Zen 3, altering the lookup table will indicate regions as being over or underexposed if you move the sliders, whereas in full range the sample is exposed OK. You can now go through your other channels and adjust imaging as required. It is often worthwhile increasing lamp intensity and reducing exposure times for channels to keep imaging times low, especially on tiled and multiwell images. Once you are happy with the exposure settings, clicking Snap will take an image in all of your channels sequentially, which you can visualize as an overlay or as single channels. Best Fit will adapt the on-screen LUTs to aid visualization without altering the data. If you were to change lenses, or in this case Optivars from 2x to 1x, and take the same image, the exposure times required are completely different, so will require modification if you change magnification. To map on the navigator the exact position of your sample, you can utilize the tile scanning abilities of the system to produce an overview map. This is best done at low resolution and just using a single channel. Start by opening the Tiles option, which will allow the option of an overview scan. You can work the system in carrier mode, where you select the wells or slide you want to work on, and then ask the system to part fill the region with a tiled region. Alternatively, if you switch to contour mode, you can draw a region on the navigation tab which you would like to tile. To delete the tile, select it, and from the list, delete it. The easiest way to find your sample on this system without the option of eyepieces is to use this tiling feature. So once you have the region where you think your sample is, you can select the Preview Scan tab and select a single channel, check its acquisition parameters, and reduce the number of tiles required by switching to the lowest magnification. Once you are happy with the settings, click on the Start Preview tab as opposed to the Start Experiment button. You will now see the system begin to tile the region of interest and visualize the sample. Once complete, you can delete the tile region from the menu. You can then select the Contour tool and draw around your sample more carefully. Note that as you change lenses, the estimated number of tiles changes and the displayed field of view of the camera adjusts. You can tweak the selections manually by adjusting the boxes so that the number of excess images is reduced. Go live and move the view to the middle of your image. Adjust the settings as needed and then focus your sample. Note the Z position that the microscope is currently focused at on the right-hand side and the Z position of the created tiles. These may not be exactly the same depending on when you drew your tile contour. I will take a tiled image on the other channels now on the two tiled regions selected, checking exposure and then selecting Start Experiment. The system will now take a two-channel image of your regions of interest. Once complete, you can scroll through the separate scenes, view both at the same time, and zoom in and navigate around your image. Instead of tiles, we can take multipositions across the sample. In the Tiles menu, ensure you have removed any tile regions and use the Positions tool to choose areas of your sample. Click the plus button to add them. Here I will add 4 positions. Once set, we need to verify the focus plane. Click the Verify Z positions. This opens a window where we can move from each position and check the focus. Go live on the sample, and here I use Find Surface to find the approximate focus. The sample is dim, so I'll adjust the lookup table to visualize it. Using the mouse scroll wheel with the control button, I can fine-tune the focus. Once done, click Set Z and move to Next. Repeat for all the positions, and then close this window. Now you're able to run the experiment, and it will capture the 4 positions in their different Z planes, storing all these in one CZI file with a position slider. As you can see, some of the image is not completely sharp. Therefore, we need to employ a focusing strategy. So I'll close up some of these tabs I don't need anymore and concentrate on the focus strategy options. No focus strategy will use the current Z position for imaging. Software autofocus will use a single channel which you can set manually and carry out a small Z stack and select the best in focus region at positions across the region of interest, which is either every tile or at a set number of tiles per image. You can also ask the system to carry out the autofocus per tile region on the first or center tile. To mimic what the autofocus will do, we'll go live on the Alexa Fluor 488 channel and use the Find Focus button. And you can see the sample focusing stepwise through the current field of view. I will unfocus and change the autofocus conditions a little. Auto mode is default and usually works fine. Similarly with quality on default. Full will carry out a complete Z stack from top to bottom over the range, whereas Smart will employ a quicker decreasing step size protocol. Both use the range either automatically set, depending on the lens, or manually set. The next focus strategy is definite focus, which utilizes an infrared LED to measure the cover slip or sample and uses this as a reference point. Definite focus can also be set on a per tile or tile region basis. When you start your experiment with definite focus enabled, it measures the offset between the current focal plane and the position of the cover slip, assumes this distance to be constant, and then periodically measures and adjusts focus to this offset. So ensure you're in focus on your sample before starting with definite focus. Definite focus also assumes that the sample is parallel to the cover slip, so may not work in all cases, for example thick tissue sections mounted on slides with a cover slip overlaid. It is, however, faster and less damaging to your sample, as it does not require constant illumination while carrying out a Z stack in the way that software autofocus would. Note you can see the system stabilizing every nth tile at the top of the screen. The next focus option is to combine software and definite focus, so using autofocus to determine the focal position and using definite focus to maintain that offset. This is useful in automated experiments where you cannot manually set the definite focus offset. The final focus strategy is using focus as defined by tile setup, so using the position you were at when the tile was created. So for example, if I defocus a sample, create some new tile regions with the current out of focus set position. I can then use the Verify Tile Regions tool to set the correct focal position for each tile separately by going live on each of the positions, focus either manually or using Find Focus, and then we can set the current position for each tile separately. Z-stacks will allow you to create images of different focal planes in your sample. So here I move to the 20x and focus on a blood vessel in the sample. I alter exposure again, then find focus manually. I can now take a single frame snap image, or can use the Z-stack option to set a range around the current plane of say 10 micrometers. You will notice the optimal button, which sets the correct sampling steps as determined by the characteristics of the lens. You have the option of full Z-stacks per channel or all channels per slice. This will determine how quick you can take the image, though in this case with no filter movements, the requirements will be similar. If you were to be using one of the different filter options between tracks, then carrying out a full Z-stack for each channel separately may be quicker, with the system returning to the start between channels. Clicking Start Experiment will take the images with your selected settings, and once complete you can scroll through the images for each Z plane, view the ortho view or 3D view. The other options for Z-stacks is to set the top and bottom manually by scrolling in live view to the positions you require and clicking Set First and Set Last. You can see the relative position shown in the Z-stack window. You can also alter the number of slices or the interval to your preferences. Going back to the Tiles menu, you can now revisit the regions you've already set up. But by selecting time series, you can ask the system to return to the same position repeatedly for live cell imaging. The settings I have here all seem fine and take about 10 seconds to do each set, so the time series is looping. Once you've completed your imaging, you will notice an asterisk beside your sample indicating your image is not saved. If you right-click and save as CZI, by default you would save your images on the Z drive. Using user data, month folder, and then a folder with your name. Save the file here, and then you can close the file. If you select Close All, you can choose to save or discard the files as a selection is required. If you go to File Explorer and see where you've saved the files, they can be reopened. If you wish to save your experimental setup, you can save using the cog icon so you can come back to the experiment at a later date. As it will remember your experimental settings, anything which is highlighted in blue in the Setup tab will be recalled. Filters, etc., lenses, etc. However, this is on a track-by-track basis, so ensure your settings are correct. Lenses do not tend to be included in the default, so that whatever you currently have the microscope on is set to, otherwise different tracks can be set up with different magnifications. If you use a sample of a different type, eject the sample, place a new sample in the holder, then return to the PC. Do not load the plate using the LCD screen. Choose a new sample carrier, then load the new sample. You will also notice any existing preview scans remain in place. These can be deleted by clicking on them and pressing delete. You will get a warning that the sample carrier in the experiment is different. You can either adapt the experiment to use a new sample carrier and save it as a new experiment, or leave it alone and create a fresh experiment. If you are using a multiwell plate, in this case a 96, the alignment of the template in the image may not be exactly correct, but this is easy to adjust. Again, go to a wide field of view with a low magnification, check that your imaging parameters are correct, then go live and focus on the edge of well A1. If you go to the Tiles menu again, ensure you are in live mode and click on Calibrate. You can do it manually, as we will do now, or ask the system to attempt it automatically. This is the same as clicking the Auto Carrier Calibration option in the Sample tab. Ignore the first page as you have already set conditions, and pass on to the second, where it is best to leave the 7-point edge detection on, as this will adjust position and size of the wells. Click through to the third page. Make sure you are able to see the edge of the well on the screen. Adjust the lookup table as required. Double-click on the far left of the visible well, then click Set Position. Now click Move Stage, and the system will move to where it thinks the top of well A1 is. Double-click on the image to recenter as needed, then repeat for the right and bottom edges of A1. Click Next, and the system will move to A12, and repeat the recentering, though this time it only requires 2 points. Press Next again, and the system moves to H12 and requires one last point calibrating. This is usually fairly accurate. Click OK. Now go back live and navigate around the plate. You will notice that the positioning of the template is more accurate than before. Tiling setup on multiwell plates is again very easy. Select the well you wish to tile in the navigation window so that they are highlighted in blue, and ensure you are in carrier mode. You can now fill the proportion of the well you wish to tile. I would of course make sure to set focus, etc., but if you are at the point of having an experiment set up which you would like to run, save the experiment. If you are wanting to use a particular experiment with robot automation, a good test to see it will work is to eject the plate, reload the plate, then immediately press Start Experiment. If the experiment runs in focus correctly with no intervention, then it will be usable in an automated workflow. This can take a little tinkering to get calibration and focus strategies to work, but once done, you should be able to run multiple plates completely hands-free. There are another couple of controls on the right-hand panel to be aware of, including the auto immersion reservoir bottle. As you can see, there is a warning saying empty. In this case, the 50x lens would not be usable. The system is usually topped up, but if needed, open the front panel of the CD7 using the silver slide under the touchscreen and replenish the reservoir with autoclaved DI water available in the facility. Empty the waste tank at the same time and replace the reservoirs back in the system, ensuring no kinks are evident in the tubing. If the reservoir has just been refilled and you require use of the 50x lens, you may need to create and remove immersion several times to remove air bubbles. Your experimental time series can be carried out under environmentally controlled conditions by switching on the heating and CO2 controls on the side panel. Note that the entered value may not be completely accurate, and manually calibrated values will be noted beside the PC. In this case, 37 degrees C and 5% CO2 actually requires settings of 38.5 and 6%. The pump level should be set at 7 to 9. Check the bubbler water reservoir behind the CD7 panel and top up as required. The heating takes about half an hour or so to stabilise, so it is best to preheat the system and place your plate directly from the incubator. It is also best not to leave the loader door open between plates for this reason. Once you are finished with the CD7, ensure all your files and experimental setups are saved. Ensure that incubation and CO2 has been unchecked and the pump switched off. Click to eject your sample and close Zen. At this point, you can copy the files you created to the RDW store manually, as the CD7 does not run on auto backup service. You can shut down the PC if there's no one booked on the system after you, and you can remove your sample from the tray. Close the tray using the controls on the touchscreen before switching off the CD7 with the soft button beside the LCD.